Hi there. So I found one of the question, which is the statement is here. So there's a like I'm solving the relative velocity questions, and I found this question, which is kind of the difficult part. It has the one or two things in like the difficult level. So let's try this question. So the velocity of a boat, which is in a straight river, flows. So I think I found this thing which is like pretty straight now. So the river is flowing due east, okay, with this much speed, and a boater that starts at the south shore of the river and heads in a direction 60 degree from the shore. So um, for this, I think we have to draw the diagram. And for the diagram, what I'm gonna see, so let's say right here, yes, I have enough space to draw the diagram. Okay, so the river is going down east, right? It's going down east. So I'll take this east direction. So that means the river is going down this direction with speed of 10 miles per hour. Okay, and the direction of the boater is not in the either one of the directions. So he said like at the south shore of the river heads in a direction from the shore. So he's kind of going from the shore. So the shore is right here, and he's going at a 60-degree angle with respect to the shore. So I'll take this the direction of the boater or the boat, this one here, which is at 60 degree, and that is given as 20 miles per hour. Okay, so first question we have, express the velocity of the river as a vector in component form. So we know, like from the diagram we found that the river is not moving in an inclined direction, so it has only straight direction towards east. Now if you take the reference of the east as x-axis, so the first part would be the velocity of the river vector will be 10 in the direction of x-axis. So I would say like 10 I cap, or I would say like 10 miles per hour due east, because it doesn't have any other component, right? So that is it for the first part. The second part I have B, which is express the velocity of the motorboat relative to the water as a vector in component form. So this is pretty interesting because I have the velocity of the boater, which is 60 degree with the direction of the river, right? So that means I have to resolve this into two components. So what I'm going to do, I'll draw another diagram right here, and I will include only the 60-degree component. So this will be the cos, because this is adjacent, so that will be the border cos component, which is along x-axis, and this will be the y component of the border. So this will be y-axis component. Okay, now so we're gonna do like this is 20 mile per hour in the inclined direction. So this would be like the component would be something like this. So the velocity of the motor will be, so I have now two components, the one along x-axis, the second along y-axis, right? So I will say the x-axis component is vb cos 60 I cap, because that is along x-axis, plus vb sine 60, which is along y-axis, so that is j cap. That is how you can write down the components like this, and when you plugged in the values you will get something, like in the numbers. So the third part we have, find the true velocity of the motorboat. So what will be the true velocity? So the true velocity would be, let's calculate the, like let me calculate these values, then I plugged in the values directly. Okay, so I calculated those values, and I found it at something like this. So 10 like this one will be 10 I cap, plus this will be 17.32, and that is j cap. So this is the value of the voters true like the velocity in the vector component. And when we're looking for the true velocity, right, when we're looking for the c part, the true velocity, that means I will add the x component and the y component of the water and the river. So this is very interesting part, and I will get the square root of that after when you are calculating the magnitudes. So first of all, the true velocity of the water with respect to the river. So this is how it is, and that could be the water component of the x-axis is 10 I cap right here, right, and the river component is right here 10 I cap. So I will simply add like 10 plus 10, that becomes 20 I cap for the x component, and the y component, it doesn't have any y component, right, this is 0 j cap. So I will mention there, so 0 j cap plus 17.32 j cap. So that is it for the velocity component, like magnitude, sorry, the what I'm trying to say. Okay, the velocity, the true velocity. Okay, when you are calculating the magnitude, like the fourth question I will show you here. So they said true speed and direction. So the true speed will be the magnitude of this vector right here. So it will be something like this, which will be the square root of 20 square and then 17.32 square of that. So when you solve this one, let me see how much it will be. I'm sorry, like I totally forgot to unpause the video, but that's fine. Okay, so what I got, like this was the magnitude was there, and the I don't know like which one was it. So, anyways, just think about this. Like I have. Okay, I think this one was done in the video. Okay, just look into the solution and let me know if you still need help in it.